Hi, welcome to lesson number 1, module 6 of the Apache Spark and Scala course. So in this particular lesson, we will be introducing Spark Streaming. Now before we proceed, let's quickly recap the last module and the last lesson in the last module. So in the last lesson, we were learning how to work with JSON and Parquet files in Spark SQL. We also saw that even we can read a JSON file and convert it into a Parquet and store it, or you can read a Parquet and do vice versa. So the objectives for this lesson is to understand the concept of Spark Streaming and what are the features, some of the use cases in the industry, and how a streaming system is designed, and what are some of the common challenges in designing a streaming architecture. So if you look at Spark Streaming, it is an extension of the core Spark APIs. What this actually means is that whatever you are doing on Spark Streaming API, it will be inherently converted into Spark core and then executed. Now the advantage is that you can run streaming processing on hundreds of nodes and you can have sub-second delays, and the data can be taken from a variety of types of sources. Either you can have the data from Kafka or from Flume or directly from HDFS or cloud computing related streaming systems such as Kinesis or even social media such as Twitter. And Spark Streaming is very efficient and fault tolerant. What this actually means is that even if the machines or the systems fail, Spark Streaming can recover from there and continue the streaming operation. And the API is very simple to program as well. So let's see what are the advantages or the great features of Spark Streaming. So first of all, it is very easy to use. Now, why we are saying it is very easy to use? If I have to compare Spark Streaming with something else of a similar type, it should be Apache Storm. So before the invention of Spark Streaming, people were using Apache Storm for building streaming applications. And Storm is a good tool, but the problem is that you have to learn the technology separately. You have to install a Storm cluster. You have to manage it. So it's very complicated. Now Spark Streaming is just an extension of core Spark. So the learning curve is very less and it is very easy to use. And obviously you can integrate Spark Streaming with Spark. And like I said, it is fault tolerant. So even though you are running it in the main memory, right, it can recover from failures, you can recover from missing data as well. Now the core idea in Spark Streaming is something called discretized streams or D streams, and we will see that. Now the D streams are created in such a way that you get high throughput. And obviously, last but not least, you get tremendous amount of scalability and you can scale to hundreds of nodes. Now let's have a quick look at the history of Spark Streaming. And we are all aware that in the late 2011s in the AMP-Lab Berkeley, the idea of Spark was created. In 2012 quarter 2 only, we got the prototype with Spark Core. Where it was running small jobs, and then somewhere in quarter 3 the core improvement and open source functionality of Spark came, and in February 2013 we got the alpha release, right? And in January 2014 only we started getting a stable release of Spark along with Spark Streaming. Now this slide is actually taken from Databricks, and this is the brief history of Spark and Spark Streaming. So what are some of the industry use cases of Spark Streaming? So the first one is credit identity. So an example will be a credit card which is being used for a fraudulent transactions. So let's say that you are working with a very famous banking client, and imagine the client has millions of credit cards in circulation. Now, whenever a transaction on a credit card is made, that transaction has to be analyzed in real time to identify whether it is a fraud transaction or not. So let's assume, for example, that a credit card, a particular credit card, was swiped in the New York City at 10 o'clock in the morning. Now the same card was swiped in San Francisco at 10:30. Now we can understand logically that this is an impossible scenario. The customer might not be able to travel from New York to San Francisco within half an hour. But how a system can identify this anomaly? So that is where technologies like Spark Streaming can help you. So in this example, all the credit card transactions will be fed into a Spark Streaming application, and this application monitors the subsequent transactions in real time. And by comparing the geographical location of the transactions, the system can predict whether it was a fraudulent transaction based on the geography or the number of kilometers between the 2 points or so many other factors. So the idea here is that you will be getting a numerous or millions of transactions in a small amount of time, and the vital point here is that the system should be able to analyze all this data in real time and then make a decision. The second use case that we have is from the healthcare industry. So many hospitals are using Spark Streaming these days to continuously monitor the patient vital statistics and to take the decision accordingly. So the sensor data from patients such as heartbeats and blood pressure, so on and so forth, will be continuously read and fed into a Spark Streaming application. Now the system will already have a predetermined statistics which says that if the values are within this range, then the health condition of the patient is normal. Now, if the values cross the border, then the system can detect it in real time and then take a measure such as sending an alarm to the head nurse or something like that. The third is transportation, where you can practically collect GPS related data from your fleet, and then you can have dynamic rerouting based on the traffic in a particular area. And Spark Streaming is also extensively used in the manufacturing industry. Now, if you look at the retail and e-commerce industry, Spark Streaming can be very efficient in case of dynamic inventory management. So let's assume that you are working with a major e-commerce vendor. Now imagine that there is the holiday season going on and the e-commerce vendor has put up a sale on most of the brands. Now you have to understand in real time how many people are interested in particular brands so that you can proactively procure the numbers so that you can serve the people. So you can do this by continuously monitoring the user sales and search statistics. This will be done by Spark Streaming. It is also extensively used in surveillance, consumer internet and mobile, and digital advertisement and marketing. Now, I am quite sure that all of you could have seen advertisements which are popping up when you visit particular website. Say for example, you visit an e-commerce website such as Amazon, and then you search for a product such as an Apple iPhone, and then you close Amazon's website and you open up another website, you will automatically see the advertisements popping up which is related to the product you saw in Amazon. So this is happening because of Spark Streaming. So in real time, the user data is streamed and analyzed, and then a decision is made whether the relevant advertisement should be shown to the user or not. So Spark Streaming has number of use cases in different industry. Now let's also look at a streaming system design. Now a streaming system will typically receive the data from different types of sources. So there are two ways in which you can actually collect the data. Either you can directly consume the data into the streaming system, which is not a good solution. The proper way to collect the data is to get the data into an intermediate storage such as Apache Kafka, Kinesis, or Flume. Now the data may come in the form of live logs, or the data might come from mobile devices or social media such as Twitter, or sensor data such as Internet of Things. Now, in order to ensure that all the data is captured and stored in a fault-tolerant system, the data is first consumed in a cluster such as Kafka. And then your Spark streaming application can connect to the Kafka cluster and start streaming the data. So the data is processed parallelly in the cluster. And once you have the result, then the results are again streamed downstream to systems like HBase or Cassandra or HDFS. Now let's also look at some of the challenges related to Spark streaming. Now even though streaming is a very efficient way to analyze data in real time, today's large-scale applications makes it very difficult to do complex real-time streaming. So the first problem that we have is fast failure recovery. So what if a machine or couple of machines which are part of your streaming architecture fails? How can you recover that? Are you able to recover in a short span of time so that you can continue streaming the data? Now the second challenge is related to load balancing. So when you are receiving the data, are you able to balance the load? The third is unification of streaming, batch, and interactive workloads. Now, you have a Spark cluster, and the cluster might not be used for only one type of application. Maybe there is a batch workload which is running in the cluster. Maybe you are having interactive workloads such as Spark SQL. And maybe you also want to use the cluster for Spark streaming. So whether you are doing SQL, Core Spark, or Spark streaming, all of this uses the RAM or the main memory of the machine. So when you have a polyglot of workloads, how do you manage this? And the last is advanced analytics with machine learning and SQL queries. So in the modern era, you are not just streaming the data and applying very simple logics. You might want to do further processing such as machine learning in real-time data. So how are you able to do this kind of analysis? So this is the fourth challenge that we have. So to wrap up in this particular lesson, we have learned the concept of Spark streaming, the features, industry use case, the system design, and the problems related to the same. That's all for this lesson. If you have any questions, please do not hesitate to raise a support ticket. Thank you.